Hello, I'm audible. Good evening, everyone. My name is B. Vasukumar from Department Electronics and Communication Engineering, SRMAP University, Emertxe. Today, I'm going to present my project titled Smart Home Automation using Arduino with picsimlab and blynk. In today's world, automation plays a huge role in making our life easier, faster, and more efficient. We are surrounded by smart technologies that can automatically sense, react, and adapt to our needs, whether it's our lights that turn on when we enter a room or an air conditioner that adjusts the temperature automatically. The aim of this project is to develop a smart home automation system that allows user to control and monitor home appliances remotely using Arduino simulated to picsimlab and integrated with the blynk mobile app. The idea behind this project is not only convenience but also energy efficiency and safety. Imagine being able to check if you left the fan or light on even when you are outside your home and turning it off instantly. You are using your phone. That's what smart automation can do. In this project, we are combining hardware and software simulation using picsimlab, which is a virtual lab environmental for Arduino and PIC controller simulations. Instead of physically wiring up the components, we can test, debug, and visualize the entire systems on our computer screen. This makes it much safer, cost effective, and faster to develop prototypes. The Blinks app acts as the user interface. It's mobile application that communicates with the Arduino board over the network. With this app, users can monitor sensor data such as temperature, humidity, and water level, and control appliances like lights, fan, and pumps directly from their phones. Our goals in this project were to design and simulate a smart home automation system using IoT principles, to integrate Arduino with picsimlab and Arduino real-time control and feedback, to user sensor for automation and monitoring of household parameters, to demonstrate energy efficiency and convenience and through automation. In this later part of this presentation, I will walk you through the concepts behind IoT, CC, and C++ embedded systems, and finally the block diagramming and result of this project. Begin the understanding the foundation of the entire concept, IoT or Internet of Things. See, the Internet of Things, commonly called IoT, it is a revolutionary concept that connects everyday physical objects to the Internet. This device can collect and exchange data automatically without needing human involvement at every step. In simple terms, IoT turns ordinary devices like bulbs, fans, doors, thermostats, and even register into smart devices that can sense, communicate, and respond intelligently. For example, imagine your home lights turn on automatically when you enter the room, or your fan adjusting its speed based on temperature reading. These tasks are possible because of IoT systems, where sensors, microcontrollers, and communication networks work together. The key idea behind IoT is interconnectivity. Devices are linked through the internet, share data in real time, and allow users to monitor and control them from anywhere in the world using smartphones and computers. In Smart Home Automation project, IoT is the backbone that enables communications between the Blink app on our smartphone and the Arduino controller in picsimlab. When you tap a button on the Blink interface, the command is silent over the network to the Arduino, which processes the signals and switch on or off the connected appliance all in real time. Now, IoT can be classified into several categories: consumer IoT, industrial IoT, commercial IoT, agriculture IoT, and military IoT. In consumer IoT, this includes devices we use at home or personal convenience like smart lights, smart TVs, wearable device, or smart speakers. Our project falls mainly in these categories. In industrial IoT, used in factories and industry for monitoring machines, predictive maintenance, and increasing safety and efficiency. And commercial IoT used in business and service such as hospitals, office, and transportation systems. In agriculture, IoT is used for managing public systems such as bridges, roads, and water distribution. In military IoTs, in defense, it is used for surveillance, battlefield monitoring, and secure communications. In case our we are focusing on home automation, is a part of consumer IoT. The basic components that makes possible are sensors, microcontrollers, actuators, and blynk plus Wi-Fi. Through picsimlab, we can simulate all of these components virtually. These tools allow us to design circuits, connect sensors and actuators, and test the code before actual implementation on hardware. For example, if the temperature sensor reads more than 30 degrees Celsius, the system automatically sends a signal to turn on the fan or air conditioner. If the light sensor detects darkness, the guardian lines automatically switch on. Using the BigSim lab, the user can manually override automations. The monitor readings or control devices from anywhere. The IoT's main advantages are convenience, efficiency, and energy conservation. Reduce the need for manual control, improves accuracy, and provides data analysis for smarter decisions. However, IoT also faces challenges like data security, network reliability, and other device compatibility, which are important considering future developments. In short, IoT is the bridge between the digital and physical world through this project, and we are demonstrating this power in making our home intelligence interactive and efficient. Let's Now that we are understanding the concept of the IoT, let's move on to the program side of our project. First and most fundamental logic we use in embedded C programming. C is one of the most powerful and widely used programming languages, especially in the field of microcontrollers and embedded systems. If it is often called the mother of all programming languages because many modern languages, including C++, Java, and Python, were involved from it. The C programming provides direct access to the hardware through pointers and memory manipulations, which make it perfectly for controlling microcontrollers like Arduino. In Smart Home Automation project, there's logic that drives the Arduino controller like read sensor data processing inputs and turning on our appliance is all written in C and C++. Let's take a simple example. When we connect a temperature sensor to Arduino, the microcontroller continuously read the sensor value using an analog input. In C programming, we might use a functions like analog read to get that value. Then using simple if else conditions, we make decisions. So the beauty of the C is that both human readable and machine efficient. It allows to write compact and fast code that directly interacts with the microcontroller registers and input pins. For example, turn on the LED is easy as setting a pin high, but behind the single instruction lies complex hardware level switching handled by the microcontroller. In picsimlab simulations, we can upload the C code to the Arduino board virtually. This means that instead of wiring physically sensors and LEDs, we can simulate everything the temperature sensor, light sensor, and output devices and test whether our code works as intended. If a sensor simulated reading goes above a certain threshold, the software will trigger the respective digital output. They help us to debug logic errors early without needing physical components. C programming also provides a great foundation for modular code where each part of the systems like light control, fan control, or water pump control, it is handled by a separate function or loop. This improves readability, reduces complexity, and makes the system and user to maintain. Another important concept in embedded C is real-time control. Since our system is continuously monitoring sensor, the program runs in the infinity loop, often written as while one or loop function. So that is never stop unless powered up. This ensures that all devices respond immediately when a change occurs, just like real automated systems. Here are some of the main advantages using in C programming our projects. It allows direct hardware control. It's fast and efficient, ideal for microcontrollers with limited memory. It supports modular programming, which helps in organizing large projects. It is portable, meaning the same logic can be used in multiple hardware platforms. In short, C programming forms the core logic of our smart home automation projects. It's the brain that decides this what action should be taken when certain conditions are met. However, a project grows larger and more complex. We often need more features like acceleration, object-oriented design, and code reusability, and where C++ come in. Go to the next slide. Go to the next slide. Wait 1 minute. Go to the next slide. C++ is an extension of the C language developed by a Bulgarian startup in the early 1980s. It retains the efficiency and power of C but adds advanced features like object-oriented programming, classes, inheritance, and pulverism. In our smart home automation project, it primarily used C++ because Arduino environment itself is built in using C++. This gives access to built-in libraries and functions that make it easier to program sensors, Wi-Fi modules, and IoT communications with the blynk app. One of the one minute. One of the key concepts C++ in our project is the function. Now go to the next slide. The function is a reusable block of code that performs a specific task. Instead of writing the same code multiple times, we can define a function once it is called whenever needed. For example, in our project, we can separate functions: void control light, void control fan, void monitor temperature, void send data to blynk. The structure of the C++ function includes return type, function type, parameters, and function body. The data type is returned like int, float, or void if nothing is returned. Function name is a meaningful name that describes the task. Parameters input passed to the functioner. Function body is a set of instructions inside curly brackets that define what functions does. Okay, using function as a server entertainment, realizability, simplicity, debugging, and teamwork. These are just look at it. Okay, go to next slide. This is embedded system. What is embedded system? An embedded system is a specialized computer system designed to perform a specific task and functions within a larger system. Unlike general purpose computers, embedded systems are dedicated to controlling devices, processing data, or monitoring operations in real time. They are widely used in everyday devices like washing machines and smartphones, cars, medical instruments, and industrial machines. So go to the next slide. Here's the block diagram of the smart home automation. So let me now explain this block of the smart home automation. At the heart of the project is the Arduino board is acted as the brain of the system connected to a sensor, actuators, Wi-Fi modules, and blynk app, which detects environmental parameters like temperature, light, or water level. Actuators such as motors, relays, or LEDs that respond that to commands. Wi-Fi module which allows communication between the Arduino and the blynk mobile app. The blynk app that user interface where you can monitor and control device remotely. All of these components are simulated and tested in picsimlab, which behaves just like the real hardware environment. These setups demonstrate the working of real-time home automation systems. Go to the next slide. The sensor. The sensor plays a vital role in the project. Some of the sensors used in LDRs, temperature sensors, water levels, and motion level sensor. This is the 16 to LCD to print the temperatures and a cooler on a cooler display on here, cooler or a cooler of heater on or any top. This is the cooler. This is the Ethernet field. This is the LED. These are LER sensors. So LER sensors detects the intensity of light used for automatic guidance lighting control. Temperature sensors monitors the temperature, helps control fans or heaters. So each of these sensors are real-time data to Arduino, which process make it a logical recognition. So project demo. I will show the project demo. Okay, now I'm opening the Arduino IDE. This is the code of the Arduino. I'm just compiling this code. Okay, I will share the screen of the wireless. This is one. Share the screen. So this is I will share the screen. Say compile is done. Now I will show the output of the picsimlab in picsimlab. Okay, I'm opening the serial remote tank. Okay, I'm connecting. Recorded. So now it I hold it a minute. I load the Excel file for output. This is my loaded Excel file. I will open here. Then you see the output of the smart home automation. Yeah, see, Arduino is alive. See, output is getting. I will show my screen. So this is my output getting. Here my temperature is reading. I will show that. Wait, wait. This is the water tank. This is the tanker capacity is 3000 liters. You want to remove the water in the tank, just on the outlet button. See one getting error. Arduino is got offline. I will okay, I will load it Excel file again. Yeah, little bit error. I will solve it. Wait, wait, wait. See, Arduino is online. My showing Arduino is getting online. I will share that my screen. My output is open. Okay, 1 minute. Say 1 minute, 1 minute. It's getting so it's taking little bit time because of my software is slow. So these are working now. Fine. So there is a volume, See, I will show my screen 1 minute. Here my screen. Okay, we want only just plus this one. Automatically there is this one. I will show the temperature this one. Next I open the cooler button. Let's see here is cooler will on. Yeah, see cooler is working, but it little take time. Now it's working, but it is taking little bit time. See is working. Okay, I will heater is on. It is see here. Okay, here LED is on. I'm marking that. I opening the cooler button. This cooler is on. The outflow is on. Inflow is on. This cooler is off. Output flow is on. Off. Inflow is off. I will this heater is on. Okay, I will go to the conclusion. This is the output of the smart home automation. The smart home automation project using picsimlab and blynk shows the household devices can be automated and controlled remotely for convenience, safety, and energy efficiency using Arduino sensors and the blynk app. Users